Today I'm going to be doing the 2010 AP Calculus AB Free Response question number 3. It's a rate problem and it has a nice graph, so it's not too bad. Let's begin with the question. There are 700 people in line for a popular amusement park ride when the ride begins operation in the morning. Once it begins operation, the ride accepts passengers until the park closes 8 hours later. While there is a line, people move onto the ride at a rate of 800 people per hour. The graph above shows the rate, RT, at which people arrive at the ride throughout the day. Time t is measured in hours from the time the ride begins operation. So there's 700 people in line for the popular amusement ride when it begins, so that just means there are 700 people waiting in line initially. Secondly, once it begins operation, it's continuous until 8 hours later, so there's no starts or stops. While there is a line, people go onto the ride at a rate of 800 people per hour. That just means that people leave the line at a rate of 800 people per hour. While this graph is the above graph is a rate at which people arrive at the line. So while this is people entering the line, this is the graph of people leaving the line. It's a constant 800 people per hour. Now we can go on to question A. How many people arrive at the ride between t is equal to 0 and t equal to 3? Show your computations to lead your answer. So let's begin with a little bit of abstract math, a little bit. So for part A, we're given the rate, but we want to get just people. So the way we get from people per hour to people is using an integral. And it's asking for 0 to 3, and for people arriving at the ride. So that rate is RT. So that's the integral, but we don't know what RT is, so we have to use the graph for this. So now we get to be a little bit more visual. So an integral is just area under a line or a curve. So we go to there. So we just count up all the squares. So there are 10 squares here, 4 squares here, because we have to go past 2 to 3. And then using height times base, 1/2 height times base, we get a 1 here and a 1 here. So in total there are going to be 16 squares. But the question is not asking for 16 for squares, it's asking for people. So we have to figure out what the squares represent. Looking back at the graph, we can find that every box is actually 200 people. So we multiply this 16 by 200 to get 3,200 people. And this is people arriving between the time is equal to 0 and time is equal to 3. On to part B. Is the number of people waiting in line to get on the ride increasing or decreasing between t is equal to 2 and t equals to 3? Justify your answer. At first glance, it may look like it's decreasing between time 2 and time 3, just because this line is going down. But remember that this is just the graph of the people entering. What we really need to find is the relationship between the amount of people entering and the amount of people leaving. And that will give us the total number. That will give us whether the total number of people in the line is increasing or decreasing. So the amount of people entering is greater than the amount of people leaving. It's going to be increasing. And if people entering is less than the amount of people leaving, then it's going to be decreasing. We know that E is equal to RT. We know that L is 800. So on average it's 800. Go back to the graph. Between 2 and 3, because it's linear, we can find an average. So this average is going to be 1,000, one half of the way between 800 and 1,200. So coming back here, we now know that on average 1,000 people per hour are coming in and 800 people per hour are leaving. We now know the amount of people, there's more people entering than leaving. That's the same as an increasing. So it's increasing. Well, not at, I guess we can go between. T is equal to 2 and t is equal to 3. We have to justify, so we use a because the hashtag of people, the number of people entering the line is greater than the pound sign of people leaving. And that's part B. On to part C. At what time t is the line for the ride the longest? How many people are in the line at that time? So this is looking for a maximum value. We know that maximum values occur when the change in what we're looking at is equal to 0. It stopped increasing, but it hasn't quite started decreasing, so the change is equal to 0. We know that the change in L is equal to the amount of people entering minus the amount of people leaving. So if this is equal to 0, then E must be equal to L. We know that E is RT, we know that L is 800. So at what point is at what T is RT equal to 800? Looking back, we got 800 going across here and RT coming down here, and they intersect at 3. So when T is equal to 3, this is true. So T is equal to 3 is going to be our critical point. Now, to find out exactly how many people are in the line at this time, we have to kind of model the change of the line over time. So, between 0 and 3, the total amount of people entering the line is going to be modeled by the integral amount of people entering is RT, plus the initial 700 people that were already there, minus 800 times 3, because over those 3 hours, each hour 800 people have left the line. It's going to be equal to X. So we already found this in part A, so that's nice. That's 3,200 plus 700 minus 2,400 equal to 1,500 people max at T is equal to 3. And there's our answer for C. For part D is asking, write but do not solve an equation involving an integral expression of R whose solution gives the earliest time t at which there is no longer a line for the ride. Alright, let's just think about what that's asking first. It's asking us to find a equation which, when equal to 0, gives us the time. So we kind of already found that, right? We got this is actually how many people are in the line at time 3. So if we already know the amount of people in the line is going to be equal to 0, but we don't know the time, we just replace all these 3's with a variable. So we got integral from 0 to the variable of RT. Now we really shouldn't use the same variable twice, so we choose Rx, and that's fine. Plus 700 minus 800t. Now it might look weird because we have 2 variables and we only have 1 equation, so it's going to be hard to solve. But when we do that integral, all the x's are going to be placed with t's. So we're really fine there. So we've got 1 variable, and that variable is for time. And plugging in solving this equation would give us a time at which the amount of people in the line would be equal to 0. So that's the answer. Hope you found this helpful. And if you need some more practice with problems like these, there are more in the description. And I hope this helped.